Hi there.
45, 90, 65.3, 180.
36.527319.
See you later.
Welcome to Grablo. In this tutorial, we'll create a voice-controlled servo motor system. Ready to control hardware just by speaking? Let's get started. Create a new project and give it a name. Now let's add a new logic to build our voice control system. First, let's create a control for speech recognition. Since we never know when you'll speak, add an always type condition. Next, add a speech-to-text action. Create a new speech-to-text. For this tutorial, we'll use the AI-powered on-device speech recognition. Grablo includes a built-in model, so we'll just use that in this tutorial. If you need better recognition or support for other languages, you can download different models. Check the Grablo documentation for more details. Grablo's speech-to-text uses VAD, voice activity detection, which filters out silence and background noise, capturing only actual speech. So you can just leave it running, and it'll automatically pick up voices and ignore everything else. Select the speech-to-text we just added and set the command to listen. Simple, right? Now your microphone will pick up voices and convert them to text automatically. Now let's add a control to rotate the servo motor using that converted text. When the speech-to-text action finishes, that means voice recognition and conversion are complete. So add a watch action type condition. Select the listen action and set the status to complete. This condition triggers whenever new speech is recognized. Now let's get that converted text. Add a speech-to-text action. Select the speech-to-text we created and set the command to getText. Create a variable called voiceText and assign it. In this tutorial, we'll control the servo by speaking the angle, so we need to convert that text into a number. Add a set variable action and create a number type variable called servo angle. Click the block button next to value to open the block editor. Add a variable read block and select voice text. There might be extra spaces in the converted text, so use a text trim block to clean those up first. Then convert to a number and connect it to the return block. Perfect. Now when you say an angle into the microphone, it gets stored as a number in the servo angle variable. Time to actually move that servo. Add an I/O device control action and create a new device. Search for servo. Since we're using a Raspberry Pi in this tutorial, select the Raspberry Pi Servo Motor library. Enter the GPIO pin number where your servo is connected. For this tutorial, we're using an SG90 servo that rotates from 0 to 180 degrees. Enter the pulse width for 0 degrees and 180 degrees. These values vary by servo model, so check your datasheet. Select the servo we just added and set the command to set position. For the position value, we need the angle from our servo angle variable. Open the block editor and connect the servo angle variable to the return block. That's it! Now when you speak an angle into the microphone, the servo will rotate to that position. Pretty easy, right? Want to take it further? If you have an LCD display, let's show the converted text on it too. Add an I/O device control action and create a new device. Search for LCD and pick your LCD model. The LCD we're using in this tutorial is an I2C type, so we'll just use the default settings. Select your LCD and set the command to clear. You always want to clear the old text before showing something new. Now let's display the text. Duplicate that last block and change the command to print. For the text value, open the block editor and use the voice text variable. Our logic is complete. Let's recap what we built. The microphone picks up your voice and converts it to text. When new speech is detected, we grab that text and turn it into a number. Then we rotate the servo to that angle and display the text on the LCD. Don't have an LCD? No problem. You can use a dashboard widget instead. Create a new dashboard and add a label widget. Select the voice text variable and adjust the widget size as needed. Alright, our project is all set. Now let's get the hardware connected. Connect your servo motor to the Raspberry Pi following the wiring diagram. The LCD is optional, so you can skip it if you don't have one. Now, while the Raspberry Pi can usually handle powering one servo and one small LCD, we do recommend using an external DC 5 volts power supply for more stable operation. Oh wait, one important thing about the microphone. The Raspberry Pi's 3.5mm jack is audio output only. It doesn't support mic input, so you'll need to use USB instead. You have a few options here. You can use a USB microphone, a USB audio adapter with your existing mic, or connect wirelessly via Bluetooth. Once everything is connected, let's run the project and test it out. If you say something that's not a number, like "Hi there," the servo won't move because the text can't be converted to a number.
Hi there.
But when you say a number, like 90, it gets converted to a numeric value, and the servo rotates to that angle.
45, 90, 65.3, 180.
36.527319.
See you later.
Amazing, right? Just your voice controlling the hardware. Congratulations! You've successfully built your Grablo project. Ready to explore more? Check the links for tutorials and support. Thanks for watching and enjoy creating with Grablo.